Hello, I am Anshul from Gofodu.com, and in this video we'll look at the concept of helix. Pause and give this question a try. You see, whenever we come across a wire being wound around a cylinder, we assume that one complete turn of the wire covers circumference of the cylinder. Okay, so length of one single turn of wire is equal to circumference of this cylinder, and total length of this wire will be number of turns into circumference of the cylinder, right? But when it is clearly stated that the wire is wound spirally from bottom to top, wire is wound spirally from bottom to top. So in this case, things are going to be different. Now let me take this cylinder and zoom on this small section of this cylinder. Okay. If we zoom further on this part of cylinder which contains a single turn, okay, this is what we are going to get. And if I cut this small cylindrical piece from this side, if I cut it open from this side, what I'll get is a rectangular sheet. And in this rectangular sheet, the single turn of wire will appear as diagonal of this rectangle. Okay, this is nothing but single turn of wire. Okay, this hypotenuse of this right triangle is nothing but single turn, length of single turn of wire, and length of this rectangle is nothing but this circumference of the cylinder. Okay, the circumference is cut open to form length of this rectangle. So length is circumference. Okay, height of this rectangle or width of this rectangle is nothing but height of this small cylinder. So if I take a cylinder and if I cut it into multiple small cylinders, multiple cylindrical pieces, each piece having one single turn of wire, okay, all these small cylindrical sections will have one single turn of wire. And if I cut them all from this side and if I open them and arrange the rectangular pieces obtained in this fashion, then what I am going to get? I will get a right triangle this way. Okay, and this was length of one single turn, right? And if I have arranged these small rectangles in this fashion, what I am going to get is this overall hypotenuse as length of wire. This hypotenuse is nothing but total length of wire. Okay, and length of this small rectangle was circumference of the cylinder. If I add circumference one more time, then third time, then fourth time, and n number of times, I will get total length of this base as n into circumference of the cylinder, where n is number of turns in the wire. Okay, there will be as many rectangular sheets as number of turns in the wire. There will be as many small cylinders as number of turns in the wire. So this base is number of turns in the wire into circumference of the cylinder. And height of this right triangle will be, this height was height of a small one such section, one cylindrical section. Okay, this height was height of one cylindrical section, one small cylinder. Okay, so all these heights when added will give me this overall height. That would be height of this cylinder. This height, overall height of the right triangle, will be height of the cylinder. Now number of turns are given to me as 45 into circumference is 2. This gives me base as 90, and overall height of the cylinder is given as 56. Okay, so I can apply Pythagoras theorem to obtain length of this wire, which will be equal to root of 90 square plus 56 square, which is nothing but 106 centimeters. So this is how we calculate length of wire which is wound around a cylinder in a helical pattern. All we have to do is apply Pythagoras theorem to small pieces that we obtain on cutting the cylinder about each single turn. Thank you for watching.